Hello everyone. Today we are going to talk about the operations in Python. Actually, for each operations, we have an associated operator. For example, the addition operation is performed using the plus operator. The subtraction operation is performed using the minus operator, etc., etc. There are 7 categories of operations in general. The arithmetic operators like the plus for addition, minus for subtraction, slash for division, asterisk for multiplication. Then we have the comparison operators like less than, greater than, etc. And then the logical operators like the and, or, and not operators. And then the assignment operators like the ones that use the equal sign. And then we have other operators that we're going to cover later. These are the bitwise operators, the identity operators, and the membership operators. All right, let's write some code to examine that. So I'm going to start with creating a new folder here. This one I'm going to call operators. Inside it, I'm going to create a new file, and I can call it script.py, just like last time. All right, so here I'm going to examine each of these categories of the operators. So I'm going to start with the arithmetic. So these are plus, minus. This is for the division, the slash, and then we have the asterisk, and then we have the double asterisk, and then we have what else? We have the double division, like that. So the first one is the plus operator, and this one needs 2 operands. So one on the left and one on the right. So we can have 3 plus 4, something like that. So the result is going to be 7. Now we want to do something with this value. So we may want to assign it or print it. So we can print it, like we can say print, and then print 3 plus 4, or we can assign it to a variable. So we can say, for example, A assigned 3 plus 4, right? So in both cases, we used the value of 3 and 4, 3 plus 4, which is 7 here, and we used it in a context. Here, in this context, the print function can take an integer value. So the integer value is 3 plus 4, which is 7, and it can print it. In this context, the 3 plus 4, it's a value, and then we can have it in a variable, A. If you want, you can actually print A as well. So we show 7 and 7, right? So if we run this, you see here 7 and 7. Then we know how the plus works. If you want, you can add as many numbers as you want. So you can have B, for example, assigned 3 plus 4 plus 5 plus 6. So the way it works is that it will add 2 numbers at a time. So the operations are going to work from left to right. So 3 will be added to 4, and the result here becomes 7. And then 7 will be added to 5, and the result is going to be 12. And then 12 will be added to 6, and the result is going to be 18. So if you print the value of B, then it will show 18, as you can see, right? So this is basically how it works. And you can have other operations like the subtraction operator, which is the minus. So you can have C assigned 4 minus 3. And you can actually have D assigned B minus C, right? So remember, you can have an expression like this, like you can have 4 minus 3. These are 2 integers, so the result is going to be 1. Or you can have this expression. And in this expression, we have an assignment to D, and this assignment will take the value of B minus C. So we need to get the value of B, which is this one. I think it's 18. And the value of C, which is 1, right? And then subtract, so it's going to be 17. And this 17 will be taken and put into D. If we want to print D, you'll see that 17, right? And then we have the multiplication operator. So we can have, for example, U assigned 2 times 3. And if you print it, it will show 6. And then we have the division of 4 divided by 2. This should give us 2, right? Just like that. So you see here, it's 2. If we say 3 divided by 2, then you will see here that the value is 1.5. Generally, it makes sense because 3 divided by 2, everyone is going to take 1.5. Usually in programming, this doesn't work this way because 3 is integer and 2 is integer, so G must be integer as well. And that means G should have 1 instead of 1.5, right? Like in other languages like C and C++, usually G is going to be 1, not 1.5, because G must be integer to match the 3 and 2. However, in Python, it doesn't work this way. But if you want to show only the integer part, you can use another operator. So if we have, for example, h assigned the value 3 divided by 2, so instead of having 1 slash, we can have 2 slashes like that. So let's see the value of h. You see here, the value of h is 1, right? Because this kind of division here is called integer division. It will keep the type of h to match the first operand and the second operand. So here we have 3 is integer and 2 is integer. Then the value of h should be integer as well. Operators do not work only with integers, but they can also work with float, right? So let's have a mix of operators in an expression. So let's have, for example, this, it's going to call it mix 4 plus 2 minus 1 plus 3.2 times 3.4 minus 12 plus 5, and then this will be divided by 2. Mainly, the division and multiplication will run first, and then the addition and subtraction, because the multiplication and division have high priority than the addition and subtraction. So if you look at this, which one runs first? This one is going to run first because it's multiplication. And then we have here the division. This one also will run, right? So this becomes 4 plus 2 minus 1, and then 3.2 times 3, which makes 9.6, right? And then this is going to be minus 12 plus 5 divided by 2. This is going to make 2.5. So this is going to be the expression. And then you can start from left to right because all the operators have the same priority now. So it's going to be 4 plus 2 minus 1 plus 9.6 minus 12 plus 2.5. Let's see the value of that. So let's see. So it's going to give us 6.38, right? There are other operators. For example, if you want to raise a number to the power of another number, you'll have the double stars like this one, right? So for example, if you want to get 2 to the power 3 and say print 2 to the power 3. As you can see, you can have the expression inside print, or you can have it in a variable and then you can print it. So 2 to the power 3, that's 8. So if you print this, you'll see here it's 8. And you can do this within 2 numbers, or you can say print or 2 to the power 23. So if you run this, you'll see here the number is huge already. There is another operator that is interesting, remainder operator. It's called the mods operator as well. If you, for example, say print 3 and then this operator here, then 2. So there will be 1 each and the remainder is going to be 1. So this will print 1, right? So if you run this, you see here 1. What about print 4 and then the operator and then 2, right? This will give us 0. Why? Because divide 4 by 2, each is going to take 2 without any remainders. So this will give us 0. Usually, you can use this to detect or to determine if a number is even or odd. The idea about it is when you have a number that can be divided by 2 without any remainders, then this number is even. If you have a number that is divided by 2 but there is a remainder, that means it's odd. I think that's all about the arithmetic operators. I'm actually going to call this a script arithmetic, so that we can have a different file for the other operators, like the comparison operator, right? So I'm going to write to create here a new file. In this one, I'm going to call it comparison. So we have the bigger than, the greater than, the less than, and then we have the equality. The equality looks like the assignment, but it's not an assignment operator. It will check if two values are equal or not, right? Or two variables are equal or not. And then we have the less than or equal, and then we have the greater than or equal, this one. And also we have this expression here. This one means not equal. Okay. So let's see how they work. The idea about this expression, the expression is going to have a value also, and this value can be true or false. And true or false, we call them Boolean expressions, right? So we have a variable, we can have a variable of type Boolean, and this one can hold an expression, and the expression can be either true or false. So let's do that. So for example, if we have this expression here, 3 less than 5 or 4, something like that. So if we have this expression here, 3 less than 5, this expression, as you can see here, it's a valid expression, but again, it doesn't do anything. It will compare two numbers and that's it, right? And then it doesn't do anything with the value. So we can put this in a context, and the context can be a print function or another function, or we can have it in a variable. So we can have this as a variable, and I'm going to call it condition, maybe condition 1, like that, right? 3 less than 5. So if you think about the value of this expression, value is either true or false. And usually it's like that. You are asked, or the computer is being asked, is 3 less than 5? If it's true, or if it's yes, then the expression value is going to be true. If it's false, then the expression is going to be false, and then will be put back here. So we know that 3 is less than 5, so the expression here is true, and condition 1 will have the value true. If we want to print that, like condition 1, right? And if we try to print it, you see here it shows true, right? And you can do the same with all the other expressions, right? So you can have, for example, condition 2 can be something like 4 less than 7, for example. This one, as you can see, it's false, right? This one is going to be true. We know that. This one is going to be false. And then we have condition 3. We can have something like 3 equals to 3. This is going to be here. That's wrong because this is an assignment operator. We should have something like that, right? So 3 equals to 3. So here, this expression will be evaluated first. So 3 equals to 3, that's true. And then the value true will be added to condition 3. And then we can have other expressions like less than or equal. So we're going to have condition 4. 3 is greater than or equal to 2. Actually, this expression is true. Why? Because 3 is not equal to 2, but it's greater than 2, right? So this holds true. And then we can have something like that. Condition maybe 5. 4 less than or equal to 5, and that's also true. So if you want, we can print all of them. So we can say here condition 1, and then show it. So we'll show condition 1. We have to have a comma here, right? And then we can copy that and just modify. Okay, so 1, 2. So this is gonna be 2, and 2 here. 3, 4. So if you print this, you see here condition 1 is true, condition 2 is true. I think I made a mistake. Do I? 4 is less than 7. Actually, 3 is less than 5. That's true. I should have here 4 bigger than 5, 7. And that's true. That's true. We can make this as false. So we can make this as 5 and then 4. 3. Okay. For on this, you see true, false, true, true, false. The first one is true because 3 is less than 5. Second one is false because 4 is not bigger than 7. So it's false. This one is true. This one is true. This one is false. Right? You can use variables with these conditions. So for example, we can get the age of the user, and let's say the age is 23, right? And then you want to have a variable like admitted, and this admitted is going to say if someone is admitted to a party or not based on the age. So the admitted can be something like that: age greater than 18. Or equal, greater than or equal to 18, right? So you can see here that age has 23. You can actually ask the user to enter their age using the input function. We are going to do this later, but in general, you can ask the user each time about their age, and then you want to convert the age to 18. So if the age is bigger than 18, that means this whole expression is true, and then admitted equals to true or assign the value true, right? So we can write here admitted, and you can see here that it's true, right? So next we're covering the logical operators. So I'm going to create a new file here, and then I'm going to call it logical.py, just like that. And the logical operators are the following: so and, or, and not, right? So these operators are used to combine two conditions. So if you have two conditions, like one is true and one is false, you can combine both of them together to have an expression that evaluates to true or false. Okay? So the first one is and. So if we have condition 1 and condition 2, if both of them are true, then the result is true, right? If both of them are false, then the result is false. And if one of them is false, the result also is false. The two conditions must be valid, must be true to be true. We can have an example here. Let's say someone stated that they did two things. I went to the airport. This is the first one. And then we have what? And I drank coffee. Right? This person we can consider lying if the person went to the airport but didn't drink coffee, right? So there must be the two things for this statement to be true, right? This is how we use and, right? So how to use this in coding in Python? So for example, we have a condition like 1, and this can be true, let's say true. Okay, or it can be an expression from, or it can be expressions that has the comparison operators, right? And then we have another condition 2, and this can be true as well. And then we might have condition 3, and this can be false, right? Just like that. Then if we print condition 1 and condition 2, again, and here is an operator, right? That combines two conditions, 2 or more. Like you can have and several with several conditions, right? But let's think about these two conditions. So you have a condition and another condition. For this whole expression here to be true, we must have this true and this one as true. Both of them must be true. Just like this example here. The guy went to the airport and drank coffee. If the guy went to the airport only without drinking coffee, the whole statement is false. Or if the guy drank coffee but didn't go to the airport, again, this is going to be false. This statement to be true, it has to be both true, like the guy went to the airport and drank coffee. When we use this in coding, so we have a condition that evaluates to true or false, and another condition that evaluates to true or false, and you combine both of them together, so the result must be So the result is true only if both of them are true. Otherwise, the result is going to be false. So if you run this, you see here, it's true. Why it's true? Because condition 1 is true and condition 2 is also true, right? Now, let's print something like condition 1 and condition 3. One of them is false, like this one here. Okay, so the whole expression, this expression here, evaluates true, false, right? So you see here true and false, right? And you can do this with as many conditions as you want. So we can say condition 1 and condition 2 and condition 3. So again, all of them must be true for this expression to be true. So we have here condition 1 is true, that's fine. Condition 2 is true, that's fine. Condition 3 is false, so it will make the whole expression false, right? So if we run this, you will see true, false, false. So the AND operator works in a way that it combines all the expressions together, and all the expressions must be true so that the whole expression becomes true. Otherwise, if only one expression is false, the whole expression becomes false. Now, let's see the OR operator. This guy can also combine expressions like logical expressions, but these logical expressions or conditions, at least one of them must be true for the whole expression to be true. An example, I will say, someone is going to say something like that. I will go to work, or I will go to visit a friend, right? So if a guy goes to work, this is true, regardless of what happens next, right? Or if the guy didn't go to work, but the guy went to visit a friend, again, this is going to be true. Okay, so if the guy does one of these two things, then the expression is true. So in coding, it works the same way. So we have here condition 1 or condition 3. So one of them is true, then the whole expression becomes true. So 1 is true and this one is false, the whole expression becomes true. As you can see, this one, right? What if both of them are true? If both of them are true, like condition 1 or condition 2, the whole expression becomes also true. If both of them are false, like condition 3, or we can write here false. We don't have to write the variable. We can have actually the value itself. The whole expression here becomes false. Why? Because this one is false, this one is false, so the whole expression becomes false. We can use now and an or in an expression, like a real expression. So we can have something like that. Age 23, gender male, for example. Let's say there is an example of female only party is only for adults. So let's check the age, right? So we're going to say here is adult. Is adult is a variable. It will hold true or false based on the age, right? So this one is going to have this expression age greater than or equal to 18. Okay. And then is female, right? We're going to say gender equals to female. If you think about this expression here is evaluated first, and actually it will check if age is greater than 18. Okay, so the value of this must be true or false, and it will be added to the is adult variable. This one here, it will also check if gender has the value female or not. Remember, this is not an assignment operator. This one is an equality operator. It will have a check. Okay, so gender, is it equal to female? Here in this condition, it doesn't equal to female, it equals to male. So this one is going to be false. Evaluates to false. This one evaluates to true, right? So we can have here is admitted. For someone to be admitted to the party, they have to be both adult and female. So the condition is going to be like that: is adult and is female, right? And then we can print it. So it's gotta be false. Why? Because it has to be both. If we change this to female, right, then it will be true, right? So it has to be both because we use the AND operator. What about if we use if we make it as male already, right? And then we make this as or. Here I'm not going to say female only party. We can have it as adult only party, something like that. Then this will be true. And the last operator is the not operator, right? And the not operator give you the opposite value. So if something is true, it becomes false. If something is false, it becomes true, right? So for example, if you have condition 4 here, and the condition 4 is true, right? And then we have condition, let's say 5, age less than 18. Okay. Now age has 23, so this is false, right? If we use a not in front of condition 4 or 5, it will give you the opposite condition. So for example, if you print not condition 4, this will give us false because condition 4 is true already. And then if we say not condition 5, this will give us true. So if we run this, you see here false and true, as you can see, right? So these are the logical conditions. So these are the logical operators and how to use them in expressions. Next, I'm going to cover the assignment operators. So I'm going to call it assignments. And these operators, mainly we know one of them. So the one that we know is this one. This is the assignment operator that we know. But also there is a set of other assignment operators. They are called the augmented ones. The reason for that is that you combine two operators like this guy here. So this is a single operator, even though it has two symbols. So this one, right? And then we have another one that is like that, right? So the idea is to combine two operators. One is arithmetic operator and the other one is assignment operator. We have seen before the assignment operator. So we can say just x assigned 3, right? Or we can say y assigned x plus 4, something like that, right? So you take this expression on the right, evaluate it, and then put it back to the variable here, right? So you can actually print x and y like that. And see here, the value is 3 and 7. So we know how to use that. But let's look at this, this operator here. Again, it takes two operands. So the first one can be something like x. And here we can have a value. We should have on the left a variable name, and on the right we should have a value. Doesn't have to be a value, but also can be a variable. So we can say something like y, right? So let's try with 3. This expression here translates to x assigned the value of x plus 3. We're going to say basically take the original value of x, which is 3 here, and add 3 to that. So 3 plus 3 becomes 6, and then put the value 6 inside x. So x now has 6. We can just write it this way. So we're going to say x plus equal 3. That means take the old value of x, add 3 to that, and then put it back into x. So if you print this, it will give you what? It will give you 6. You can use other operators too. So for example, you can say y minus equal, let's say 2, right? This is equivalent to y assigned y minus 2, right? And that means take the old value of y, minus 2 of it, take the old value of y, subtract 2 of it, and then put it back into y. So y originally has 7, and here u minus 2, y becomes 5. So if you print y, it gives you 5, right? As you can see. Okay, there are other operators. Okay, so we can have, for example, y times equal 2, right? This will do what? This will multiply the old value of y by 2. So what is the old value of y? It's 5. It will be multiplied by 2. This will give us 10. So y becomes now 10, right? And then you have other operators too. So you can say, for example, take the old value of y and then power it. Okay, raise it to the power 2. So you can say y, this operator here, the double stars, is used with the power, and then you can say 2, for example, here. So that means take the value of y, which is now actually 10, as you can see, and then raise it to the power of 2. It becomes 100, and then put it back to into y. So if you print y like that, this will have 100, as you can see. And you can basically do this with all the operators. So you can say, for example, again, y divided by 2. So this will give us 50, because y has the value of 100, and then you divide by 2. This gives you 50, and then put it back into y. So if you want to print it, it becomes 50. You can also have the remainder. So you can say y has this, let's say 20. So basically it will take the old value of y divided by 20 and get the remainder of that. So y is 50. When you divide by 20, there are 2 20s and 10. So the remainder is going to be 10 equals to 10, right? So y now becomes 10. So if you print it, it gives you that. So this is how also we use the assignment operators. There are other operators like the bitwise operators, the identity operators, and the membership operators, but these are a little bit advanced, and we're going to visit them later in another video. Okay, now before we leave for today, I like to push my changes to the repository. I've made some changes last time, and I would like to push them and push the stuff I made today as well. So before anything, I would like to see the status of my repository. So I'm going to write get status. Okay, so you see here that I added some files, but these files are not staged or committed, right? So what I can do is I need to stage them. So I can go file by file. So here you can see that these are added. These were added, these 2 directories. And here's this guy is just a file that was there. It was modified, but no changes were again added or committed. So I'm going to add these files. I can add the whole thing by writing the star like that. So you can do this if you know exactly what you are doing, right? Then you can use the star just like that, right? It will add everything. Now, if you write get status again, you see all these files are ready to be committed. So you can write git commit, and then here I'm going to write I'm just going to write variables and operators. This is going to be my message. Let me just remove that extra space, and then I committed that. So everything is up to date, but not up to date with so everything is committed, but not up to date with the remote branch, which is on GitHub. So if I write get status again, you'll see here your branch is ahead of origin main. Origin here means the one on GitHub, and main is the current branch. That means the one on GitHub does not have yet these changes. And in the next line, it suggests that I should push to GitHub. So if I write git push like that. I'm going to use this one, continue, right? Now it's pushed to GitHub, it's ready. Now it's already on GitHub. Now git status again, you'll see here, your branch is up to date with origin main. That means my local branch and the one on GitHub are the same now, and nothing to commit, working tree is clean because I haven't done any modifications after that, right? That's it for today. Thank you for watching. Please subscribe if you want to watch more. Thanks again. See you next time.